Hello friends. So we have a question on differential equations. We are given a differential equation such that x is greater than 0 and y is greater than 2x. It is also given that the value of y is equals to 3 and when x is equals to 1. So at a given point the value of y is also provided to us. Now in the first part we have to use Euler's method with a step length of 0.1 to find an approximate value of y when x is equals to 1.5. And in the next part we have to use some substitution to arrive a particular form of differential equation, and then in the later parts we have to solve that differential equation. So let us move to the A part. In the A part we have to use the Euler's method. So what is the Euler's method? In Euler's method, we use step by step, we try to proceed to get a particular value of y if we are given a particular value of y at a particular x. So the formula for the Euler's method is the value of y at n plus 1, that is the next step, is equals to value of y at the nth step plus the step size, in this case we are calling it h, into f of x and f of y. These are the values which are given values of x and y from where we will be starting. The step size in this case have been given in the question as 0.1. So we will take this step size as 0.1. We also know that start from 1. So the value of y1, that is at x equals to 1. We also know the value of y1 will be equals to 3. And then also we know the value of f of 1, that is the value of 1 comma 3. So we have to put the value of f at 1 and then 3. So let us try to find the value of 1.1. That will be equals to y of 1 plus the step size is 0.1 multiplied by the value of function 1 comma 3. Now how to find this 1 comma 3? For this we will have to see what is the differential equation given to us. The differential equation given to x is dy by dx equals to y square minus 2x square divided by x square. So the value of this f of 1 and 3 will be by putting x equals to 1 and y equals to 3 in the given differential equation. So the value of y 1.1 will be equals to y of 1, which is 3, plus 0.1 multiplied by 3 square minus 2 into 1 square divided by 1 square. So please note that this is the value we are calculating from the given differential equation. So the value of y 1.1 will be equals to 3 plus 0.1 into 3 square is 9 minus 2 divided by 1. So this will be 3 plus 0.1 multiplied by 7, that will be 3.7. So we have the value of y 1.1, that is the value of y when x is 1.1 by using the Euler's method. Now let us try to find the next step. So in the next step we will be using would be y 1.2. The next step will be y 1.2. So that would be calculated from y 1.1 plus the step size into the value of this differential equation when x is, next step is 1.1 and y is 3.7. this will be our next values of x and y. So this will be 3.7 square minus 2 into 1.1 square divide by 1.1 square. So we will be getting is 3.7 plus 0.1 multiplied by 13.69 minus 2.42 divided by 1.21. So on solving you will get 4.63140. Now you have understood how do we calculate the values. So for y 1.3 we will be using it y 1.2, which is this value, plus the step size multiplied by putting these values, that is 4.6 square minus 2 into 1.2 square divided by 1.2 square in the given differential equation. So on solving this we will be getting is 5.92098. Similarly for y 1.4 you can use the equation y 1.3 plus the step size is 0.1 multiplied by 5.92, this value square minus 2 into 1.3 square divided by 0.3 square, and on solving this you will be getting it 7.79542. Now let us move on to the last value of y at 1.5 will be y 1.4 plus 0.1 multiplied by 7.79 square minus 2 into 1.4 square divided by 1.4 square. On solving this you will be getting the required value of y, that is 10.6958, or this may be written as 10.7. So at x equals to 1.5 y is 10.7. This is the value of y with the step length of 0.1 using the Euler's method. So now let us see the B part. In the B part, we have to calculate or identify a particular form of differential equation using the given substitution. So we have to use the substitution as given in the question, that is y equals to Vx. For the differential equation dy by dx is equals to y square minus 2x square divided by x square. So we can differentiate this both sides. So we get dy equals to v dx plus x dv, and dividing by dx, so we get dy by dx is equals to v plus x dv by dx. So we can replace dy by dx here, so we get x dv by dx v plus this equals to y square is equals to v square x square minus 2x square divided by x square. So what we get is v minus 2, v square minus 2. So x dv by dx will be equal to v square minus v minus 2. So we can separate this variable. V dv by v square minus v minus 2 is equals to dx by x. Now we have a quadratic expression in the denominator which is factorizable. So we can write this as v plus 1 into v minus 2 is equal to x by x. Now integrating both sides, this is a standard integral. We can write the numerator as v plus 1 minus v minus 2 divided by v plus 1 multiplied by v minus 2 equals to dx by x, and here dv, this integral on both sides. And since in the numerator you will see there is 3, so we also multiply it by 1 by 3. So this will be separated. This will be 1 by v minus 2 dv by this minus this will be dv divided by v plus 1, and we can integrate this, and this is the integral of dx by x. Now we can see this will be 1 by 3 natural log of v minus 2 minus natural log of 1 equals to natural log of x plus some constant c, which can be written as c, or we can write it also as L, natural log of c. This will make it our life much easier. So this will be natural log of v minus 2 divided by v plus 1 equals to 3 times natural log of x into c. So this is natural log of v minus 2 divided by v plus 1 equals to natural log of some constant. C cube is also a constant, so we are also writing that suppose c1 modulus x cube. So this is our solution. So we have solved while we were able to express our expression into this x dv by dx equals to v square minus v minus 2. We were also able to solve this further and find the particular solution. So we have also solving the first part of c. Now let us try to find the value of c, this constant. We know at x equals 1, y is equal to 3, and using y equals to v, we know y equals to 3 and at x equals to 1, v is equals to 3. So putting v3, so this will be natural log of 3 minus 2 is 1 by 4 equals to natural log of c1 at the value of x is 1, so this will be natural log of c1 this, so c1 is equal to 1 by 4, and since x is positive we are using only the positive values, so c is equals to 1 by 4. So our solution will be natural log of v minus 2 divided plus 1 equals to natural log of x cube by 4. Now replacing the value of v using our substitution, this will be y by x is equals to v. So this will be natural log of y by x minus 2 divided by y by x plus 1 equals to natural log of x cube by 4. Now we can equate the argument. This is y minus 2x divided by y plus x equals to x cube by 4. Cross multiplying, y minus 8x is equals to x cube into y. So this comes out to be 4y minus x cube y equals to x to the power 4 plus 8x. So the value of y comes out to be x to the power 4 plus 8x divided by 4 minus x cube. So this is your expression we needed to be found in the first part of c, that is 8x to the power 4 divided by 4 minus x cube. So now let us move to. So in the second part of c, we have to identify the value of y when x is equals to 1.5. We know the expression for y is equals to x 8x divided by 4 minus x cube, and we put the value of x as 1.5. So y at x equals to 1.5 will be 1.5 to the power 4 into 1.5 divided by 4 minus 1.5 cube. So on solving this, you will get the value of y at this particular point, which comes out to be 27. If you remember in the previous part, using the Euler's method at x equals to 1.5, we have identified the value of y as 10.7 by using Euler's method. While on exact solving of this particular differential equation, we have got the value as 27.3. And you can see this is not even a close approximation. There is a large difference in this. The reason for being is this: at x equals 2, you see the expression for y comes out to be x plus x to the power 4 divided by 4 minus x cube. And when you look closely, this x cube minus 4 is, when we equate this equals to 0, we get x equals to cube root of 4, which is 1.584. So you see in the graph of this particular function, there is an asymptote close to at x equals to 1.5, close to x equals to 1.5, there is an asymptote. As a result, the variation or the x, as x is moving close to 1.58, the value of y is moving very rapidly, and as a result this approximation with the step size of 0.1 is not very good, because of reason being the sudden gradient near x equals to 1.58, this being the asymptote. So this is the explanation of your last part, and for more such questions and detailed explanations, do visit our website and register for updates.